okay? And really throughout the year. A lot of these are ones that you've heard of before. Some of them might be a little bit new name that you've never heard of before. Okay, so we're talking about number of sides. Well, 3 is the least number of sides that I can have. If you only have 2 sides, you don't make a figure, right? So 3 is the lowest number of sides that we can have. If we have a figure that has 3 sides, we call it a triangle. Okay, I was a little nervous there. Okay, we've seen triangles before. Okay, and there's going to be all kinds of different triangles that we're going to talk about throughout the year. But just a real basic 3-sided figure is a triangle. Okay, now 4, when we think 4-sided figure, what do we typically think of? We think a rectangle, we think a square. There's a lot of different figures. And those are 4-sided figure, but I'm just talking about a generic 4-sided figure here. We call that a quadrilateral. Doesn't have anything specific like right angles or congruent sides or anything like that. It's just 4-sided figure. And then when it gets to like a square and a rectangle, those are like more specific types of 4-sided figures. There's still 4 sides, but a square would be a specific quadrilateral because it has more specific information. Okay, 5. Famous building in Washington, D.C. that houses like the CIA and some of the big government offices. It was actually one of the buildings that got hit in 9/11, and one of the planes hit the Pentagon. And it's like a big, and so it's a 5-sided figure, and each of the 5 wings or sides kind of house like different government departments. 6, hexagon. You may have heard that one before. Okay, 7 is not a very common one. We don't hear this one very often. And we won't see very many 7-sided figures in geometry. 7 is what we call a heptagon. Sometimes it's referred to as a septagon with an S instead of an H. This book, heptagon is the word they use, so we're going to go with heptagon. Okay, 8 would be like a stop sign. When you pull up to a stop sign, it has 8 sides, and it is an octagon. You're going to see these prefixes, like an octopus has 8 tentacles. That's why it's got its name, right? An octagon has 8 sides, so the prefix oct means 8. 9 is a nonagon. 10 years is a decade. You might have heard that before. 10 sides is a decagon. So the prefix dec, D-E-C, means 10. Hey, notice we kind of skip over 11 because 11 is a figure we hardly will ever see. Maybe never. And what's that? It doesn't have a special name just because we don't see it very often, and so we're going to, anything, and we'll include 11 in this, but anything bigger than 12, because we don't see it very often, we just call it an 11 gon. We just use the number with gon. And so just 11 gon would be the way we would call it. It might have a special name, but we don't use that special name hardly ever, so we'll just call it an 11 gon. And then 12, we just add the prefix do, and so it's dodecagon. And then when we get anything higher than that, when we get to like a 13, 14-sided figures, because it's so many sides, we just won't see figures like that very often. So if we happen to see a 15-sided figure or talk about a 15-sided figure, we'll just call it a 15-gon. We just put the number of sides with the suffix or the ending gon. Okay, convex versus concave. So convex, all the sides are pointing outwards, okay? As we connect the 4 sides together here, and it doesn't have to be a 4-sided figure, I just drew you an example of what a 4-sided convex polygon would look like. All the sides are pointing outward. Concave, when I think of the word cave, okay, cave is going to go inside, right? If you go tour a cave, you're going inside of the cave to look at it. Well, same thing here. If something caves in, we have two sides that go inside or inwards rather than flexing out. So I kind of think of it as flexing out or flexing in. And this one is going to be flexing in. Okay. Another way to tell this is if I were to draw some diagonals, as I draw the diagonals, then I'm not crossing any sides or any points, okay? But if I were to go from one side across here, I can't do it without touching this inner point right here, okay? And so, like, for instance here, if I were to connect those 2 points together, it's outside of the figure rather than all inside of the figure. So when you connect vertices together, are the vertices connected all inside, or is some of the line on the outside of the figure? That's another way you could kind of tell. Okay, so on parts A and B down here, we're going to classify it by its number of sides, and then we're going to determine whether it's convex or concave. So on part A, what type of polygon do we have? Okay, it is concave because it's caving in. And it's a concave, and then how many sides does it have? 4. Okay, so we would say that this is a concave quadrilateral. Okay, when we see the word classify, classify tells me what type of polygon do we have. Okay, part B, how many sides do we have? 6, okay. And are the sides all pointing out, or are any of them going inward? They're all going out, right? So this one we would say is a convex hexagon. Okay, one of the big topics for today is going to be perimeter and area. When we talk about the perimeter of any figure, triangle, rectangle, whatever it might be, then we're talking about the distance around the outside of it. Okay? How far do we go around the outside? And when I think of perimeter, I think of like a fence that goes around the outside of the yard. Okay? We're going to talk about how much area we cover, and then the area would be like how much is inside of that fence, and that would be our area. Good morning. Okay? Sometimes you hear the word, like if you've ever watched like a prison movie, okay? A prison movie, sometimes you hear the word perimeter, right? Secure the perimeter. You might have heard that term. Well, what that means is make sure everything's secure on the outside. We can't let anybody get out, right? Maybe somebody's trying to escape, and so they'll say secure the perimeter and make sure everybody's looking on the outside of the prison for whatever they're trying to find. Okay, these are the 4 figures that we have to be able to find perimeter and area of. Okay, a triangle. Triangle, we just add up all 3 sides. We find the length of all 3 sides. We add all 3 sides up. That gives us the perimeter. For area, you might have heard this a couple of different ways. What we have here is 1/2 base times height. Sometimes you might have heard it referred to as base times height divided by 2. You guys have seen the area of a triangle before? Yes? No? Yeah? Okay. Base times height divided by 2, or 1/2 base times height. Both mean the same thing. Okay. I'm going to skip over square and go to rectangle here first. Rectangle, notice the formula here. We're adding up all 4 sides. But what do I know about the 2 lengths? What do these markings here tell me? They're the same. And see how it has that double marking? We haven't really seen that a lot yet this year. This double marking means these 2 sides are the same and the 2 widths are the same as well. Okay? So we have 2 lengths and we have 2 widths. We're going to add all that up. That gives me the perimeter. So the distance around that rectangle is my perimeter. To find the area, we simply just take length times width. Now, going back to square, a square is a specific type of rectangle, but what's special about a square as opposed to a rectangle? What makes a square special? All the sides are the same, okay? So instead of saying 2L plus 2W, which would still work, because we only have one side length and all four side lengths are the same, I could just say what is 4 times S. So if this was like 8, I could do 4 times 8, and that gives me my perimeter. It's not wrong to do 2L plus 2W. That would still be okay, but we don't necessarily have to do 2L plus 2W because we only have one side length. And that's what the S stands for here. Okay, and maybe that might even help you guys is to say S is the side length. Over here, L represents length, W represents width. For the triangle, B represents the base of the triangle, H represents the height, just so we kind of know what those letters represent. We try to use variables that represent what we're talking about. Okay, we're not just using X and Y. We try to use B to represent the base of the triangle, or length and width and those kind of things. Okay, now parallelogram, notice we don't have perimeter for this. If we had to, I could find all four sides of the parallelogram and then add up all four sides. But area is going to be the big one for parallelograms. Now notice that the height here, what's happening with the height and the base? What do you notice is special about those two? Yeah, what's this little square right here mean? It's a right angle, okay? So the height has to be perpendicular to the base. It has to form a right angle, okay? We can't use one of these sides because the two sides are not perpendicular to the base. Same thing was true over here with the triangle. The height must be perpendicular to the base in order to be the true height. So in all cases, I'm going to say H has to be, or let's say form a 90-degree angle with the base. Okay, has to be perpendicular. Okay, and that's where you see that square come into play. Okay, let's look at some examples of these. If we start with these top two, find the perimeter and area of each shape. Okay? Let's start with the one on the left. What kind of figure do we have? It's a rectangle. Okay? We know it's a rectangle because it has four sides and we have four right angles. And so what I can do here is I can mark the opposite sides. It doesn't come right out and tell me this, but we know it's a rectangle, so we know opposite sides are congruent. So if I wanted to find the perimeter here, this is my L, this is my W, length and width. So we're going to do 2 times 86 plus 2 times 51. And then we can plug that into our calculator. 2 times 86 plus 2 times 51. Let's see what we get. If you got your calculator, plug it in. If you need a calculator, you can go grab one from the yellow box over there. You're going to need one today. Bless you. Okay, anybody get it? 274. Okay, and then we are going to label, okay? And here we're going to label it inches. 274 inches. Area is length times width. So this would simply just be 86 times 51. So we just multiply those two together. Okay, 4,386 inches squared. Okay, so that one's pretty straightforward. Okay, the one on the right, what kind of figure do we got? Got a triangle. Okay, we got to identify what kind of figure we have. So now we know that, first of all, perimeter, we're going to add up all three sides of the triangle. 13, 13, and 10. We're not going to use the 12, because what does the 12 represent? Yeah, 12 is your perpendicular height. It's the inside of that figure. It's not one of the sides of the triangle. So we're going to go 13 plus 13 plus 10. We just add up all three sides. And that would be 36 centimeters. Hey, the area is base times height divided by 2, or 1/2 base times height. I like base times height divided by 2 because sometimes people freak out when they see fractions, right? And think, oh gosh, how am I going to put that into my calculator? So sometimes I think it's easier just to do base times height divided by 2. Just make sure that our label, whenever we talk about area, is always square units, square inches, square centimeters. We're talking about like how much carpet do we need to carpet like a living room, okay? Or how much tile do I need? Or how much grass do I need to cover the backyard inside my fence, right? That would be how much area we're covering. I want to cover the entire space. And when you go to like Lowe's or Home Depot and you're looking for some carpet to put down, then you would need to know how many square feet you would need to cover that space. Okay. On this one here, okay, first thing that we're going to do is we're going to plot the 3 points that it gives us. And it tells us that we have a triangle. This little symbol here means triangle, DEF. Because we have 3 points, we know it's going to make a triangle. Okay. We're going to plot the 3 points first. So we're going to go over 1, up 3. We're going to label that D. We're going to go right 4, down 3. We're going to label that E. And then F, left 4, down 3. Make sure you plot the points correctly first, because if you plot one of those points wrong, that's going to throw off everything in this problem, okay? That's the most important part of the entire problem. We're going to connect these together. Okay, and it's very similar to what we did just a second ago, except they don't tell us what the lengths are. So now we're going to have to go about finding out what the lengths of these sides are. Okay, I'm going to start with the area first because I think the area is a little bit easier, and then we'll find the perimeter second. Okay. So let's do base times height divided by 2. Hey, when I find the base, I need a height that's perpendicular to that base. So if I call FE the base of the triangle, then I need a line or a segment that's perpendicular to that base. So I'm going to go from D down and draw a perpendicular segment into it, okay? Because this is a graph, it's a graph paper, then we know all vertical and horizontal lines will make a right angle, okay? Can we look at FE and know how long it is? Can we just count because it's horizontal? Yeah, right? That's what makes this one easy. If I wanted to say how long is it from F to E, I could just count because it's horizontal. 1, 2, 3, 4, 5, 6, 7, 8. So the base is 8 units long. Okay, what about the height? Can I just count for my height? Does the height have a slope to it? No. Okay, it's straight up and down. So if I wanted to count from D down to where this base is at, I'm just going to count 1, 2, 3, 4, 5, 6. As long as it's vertical or horizontal, we can count because I'm just counting how many units. And so here we know H is 6. So we're going to do 8 times 6 divided by 2. and that would be 24 units squared. Okay, that's area. Okay, questions on that one? Just using the coordinate plane to come up with the info that we need. Okay, perimeter is a little bit harder. How many sides do we have? We got 3, right? We got a triangle, so we got 3 sides. I have to find the length of each side. Okay, one of the sides is really easy to find. Which side is the easiest to find? The base, right? We already know the base. The base is 8. So we already know the length of that side is 8. That's the easy one. Okay? The other 2 are harder, guys, because they're diagonal, right? They're slanted. We can't just count. We talked about this last week. If we have 2 points that have a slope to them, then I can't just go from F to D and say 1, 2, 3, 4, 5, 6. What do we have to do? Which thing? Distance, yeah. And remember last week we talked about this good old formula that we can use to find the distance between 2 points if it's not easy to find, if we can't just count it. Okay? So F and D. We're trying to find the distance between F and D. So we're going to use these 2 ordered pairs, F and D. I'm going to kind of do this over here to the side. -4 minus 1 squared plus -3 minus 3 squared. Okay, and when I graded the quizzes, probably the most mistakes were just little mathematical mistakes. Addition, subtraction signs were where we made a lot of mistakes. Okay, -4 minus 1 would be -5. If I square it, I get 25. -5 times -5. -3 minus 3 would be -6. -6 times -6, or -6 squared, would be 36. 25 plus 36 is radical 61. That is not a nice perfect square, okay? So what I would encourage you to do is just leave it as radical 61 for right now, okay? This is what we call the exact value, or the radical value. On the quiz and on some of the homework problems, it said leave it as an exact value, leave it as a radical, because I don't want to round that decimal yet. I'm going to wait until the very end to round, okay? So that's my second side. This side right here is radical 61. You can label it if you want to. Okay, what side do we still have to find? DE, okay? And we're going to go through the same process. We're just using 2 different points here, okay? This time, we're going to use D, and we're going to use E. We're going to use those 2. And a lot of times what we'll do here, just so you remember which 2 we're doing, and I probably should have done the same thing over here. I should have labeled this one like DF, so you know what 2 points we're using. This one we're going to do DE. So we're going to go 4 minus 1 squared plus -3 minus 3 squared. Okay, 4 minus 1 would be 3. 3 squared would be 9. -3 minus 3 would be -6. Square it would be 36. So then that becomes radical 45. Okay, first thing I want you to pay attention to is these 2 are not the same length. Okay, a lot of times people will get this one and say, oh, that's radical 61, so that must be the same thing. Okay, could be true, right? And they might be the same length, But we don't have any indication that those two are the same length there. That doesn't tell us anything like that. So we have 3 different side lengths here. So now put it into your calculator just like this. Okay? 8 plus radical 61 plus radical 45. Practice putting this into your calculator so you know exactly how you have to put this into your calculator. Make sure you get the right answer. Up here it tells us we're going to round to the nearest 100. We're going to 2 decimal places here. Okay. Anybody think they got it? Xander, what'd you get? 22.52. Okay. 22.52 units. Okay. Anybody have a question on their calculator? How to put that in? Okay. We're going to need to be able to do that tonight and obviously on the test on Friday too. So make sure you know how to use your calculator. Okay? Yeah. Need a calculator.
It's right there. I think it's because you guys did it this way. You did 8.
Anybody else? Calculator? Need help?
I did my answer.
Yeah.
With the extra. Try that way.
Yeah, but that's not how you're supposed to do it.
Well, I said that's the right answer.
Maybe it's just 2. What is it, 61? Yeah, no, you guys are whacked out.
Oh, that's why I got it. I need to close it.
It's alright. I'll see you on the big ideas. See, meet me on big ideas. I put the entire question like he has it up there. He just don't even know. You need a backslash. You don't want to just put that in. Would be too busy.
So what's happening here?
Maybe you're right.
Definitely, yeah.
So the right answer.
No, we're just pretty sure you put it in wrong.
I put it in wrong?
Yeah. You see how he has it up there? Like instead of like hitting equals, after you put the first one in, you put both of them in, it comes out.
Okay, everybody's calculator's a little bit different, okay? As I went around and helped, I think I helped like 4 different calculators. And that's the way it is. And it's okay, all those calculators are the same, yet there's a different sequence of typing it into your calculator as well, okay? The only thing I will say is different, and we may not, I don't think we'll go through this whole thing, because it's just a lot more of distance formula type of things, but just to talk about this one real quick. First of all, we have 4 points, -3, 5. One 5. 2 -1. -2 -1. Okay, how would you classify this figure? It would be a parallelogram. Yeah, it's not a rectangle because our sides are slanted and it's not going to form a right angle, okay? So this would be a parallelogram. The reason why we want to identify that is so that we know what formula we're using, okay? So I'm probably not going to go through the whole thing for perimeter here. Two of the sides are really easy to find. What two sides would be the easiest to find? The top, yep, JK, and the bottom, right? Because they're horizontal. These two, we're going to have to use the distance formula for, okay? I'm not going to go through it again just because we've done that before. I'm just trying to save some time to give you guys some time to work today. So for JK, all we got to do is count. 1, 2, 3, 4. So JK would have a length of 4. ML also has a length of 4. In order to find JM and ML, you're going to have to do the distance formula. So you'll have to do the distance formula twice. Once again, it's in your notes, okay? If you forget the distance formula, you got it from last week. It's in your notebook, okay? So, or if you want to write it down in today's notes, you can do that as well, so that you have it, okay? So for the perimeter, we just need to add up all 4 sides, so you'll have to find the other 2 sides. The area, this one's a little bit different, so this is the one I wanted to kind of spend a little bit of time with. The area is base times height. If I say that this is my base, I need to find a side that's perpendicular to it. And so what we're going to do is we're going to connect the bottom and the top sides together vertically. That forms a right angle, okay? So to go from JK to ML, we need a vertical horizontal line. So if I go down from JK to ML straight down, I'm going to go down 1, 2, 3, 4, 5, 6. Okay, so my direct distance between those two would have a height of 6. So my base is 4, my height is 6, and that would be 24 units squared. Okay, just so happens it's the same area as the one above, but it's a completely different figure. Okay, so I'm not going to go through the perimeter just for the sake of saving a little bit of time. Questions on either one of those? Okay, you're building a shed in your backyard. The diagram shows 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the perimeter and area of the shed. Okay? So the nice thing about this one, we don't have any slanted sides, right? So in order to find the length of each side, all I got to do is count. 1, 2, 3, 4, 5, 6. And because it's a rectangle, if the top is 6, the bottom is 6. The sides, 1, 2, 3, 4, 5. Because it's straight up and down, because it's vertical, my width is 5. So my perimeter would be 2 times 6 plus 2 times 5. Type that into your calculator. And we should get 22 feet. And that would be, or you could just add up all 4 sides. Some people just like to add up all 4 sides. Nothing wrong with that. Okay, what would we do to find the area of this guy? Length times width, right? What's my length? 6. What's my width? 5. 6 times 5. 30 feet squared. Really nice because it's a rectangle. Not much work to do. Okay? Unfortunately, they're not always going to be that easy and quick, but when it's a rectangle, life's pretty good. Okay. If I have a rectangle with a perimeter of 20, okay, I know one of my sides of the rectangle, okay? And here's what I'm going to tell you. First of all, 1, 2, 3, 4, 5, 6. Okay? That has a length of 6 units. The side across from it has to be the same length, right? So it also has to be 6. So that gives us 12 units already. My total perimeter is 20. So how much do I have left? I have 8, but I have 2 sides that make 8, right? So that means my 2 sides have to be what? 4 apiece, right? 4 and 4. Okay? Because 4 plus 4 makes 8, and 12 plus 8 makes 20. So I need 2 sides of 4. So there's 2 ways that we could go here. I could go up 4 and put a point here and put a point here, and that would be one possibility. Or I could go down 4. Either one of those would be a possibility. Okay? So you have 2 different rectangles you could form. If I identified what let's do the top one here. Okay? This ordered pair here, I would go, we're going to start at 0, 0. We're going to go over 1, 2, 3, 4. We're going to go up 1, 2, 3, 4, 5, 6. So this ordered pair up here would be 4, 6. The one on the other side would go left 2 and up 6. So that would be -2, 6. Okay, the one below it, we could do 4, -2, or we could do -2, -2. You don't have to have all 4 of those, okay? You just want one possibility. And in this case, there's a couple of different possibilities. We've talked about that sometimes there's more than one right answer on some of these, unless it asks for both. Okay, last one. Perimeter and area. We call this an irregular figure because we don't have a name for it, right? It's just a figure that's not a typical shape. And so what we're going to do is we're going to break it up into 2 shapes that we're more familiar with. And you could do that a couple of different ways. One way I could do it is kind of cut it in 2 parts like that. If I wanted to, I could have also drawn it this way and had a couple of different rectangles that way. So there's not a right or wrong way to split it, but we want to split it into 2 figures that I can otherwise work with. Okay, so let's work with the top up here. Okay, what's the length and width of the top? Length is 6. Okay, what's the width? 3. Okay, so that would be 6 and 3. So for the perimeter of this top part, we would do 2 times 6 plus 2 times 3. What would I do to find the area of the top part? Length times width. So we would do 3 times 6. Okay, the bottom part's a little bit tricky. Thank you. We know the length is 2. If from here to here is 3, what's the rest of this? 2, because the whole thing is 5, right? So 5 minus 3 would put this to be 2. The whole thing was 5. From here to here is 3. So the leftover is 2. So the perimeter would be 2 times 4. Because we have 4 sides of 2, right? And my area would be 2 times 2. Okay, so to get my perimeter, what's 2 times 6 plus 2 times 3? 18. So the top is 18. The bottom would be 8. So we do 18 plus 8, which would be 26 units. Okay, now here's where you got to be careful. Okay? We can't count this little piece right here. Okay, so when we're doing perimeter, there's only 3 sides here to this bottom part, right? So instead of 8, what should I have used? Probably should have used 6, right? Okay, same thing for the top part. What's this little piece missing right here? It's not going over across here, right? So we're taking 2 off of that. So this should have been 16. So really it should be 16 plus 6, which is 22. Because it cuts that piece off. My area, the top part is 3 times 6, which is 18. The bottom part is 2 times 2, which is 4. Here's kind of the weird thing, guys, is that my perimeter and my area ends up being the same thing. That's not going to happen very often. Okay? Very seldom do you get the perimeter and area piece. So don't think that it has to be the same. It just so happens on that one problem right there, they both end up being the same. Okay, there is an assignment up today for 1-4. I know today's lesson took a little bit longer. If you got some questions on your homework, I'll be here in the morning. If you want to come in tomorrow and work on your quiz corrections, I'll be here.